periodic table and electronic configuration. In my first session, I think it is better to refresh your previous knowledge. After that, we can enter into new topics. So my first question is, what is periodic table? Periodic table is a tabular display of the chemical elements which are arranged on the basis of atomic number. Then what is atomic number and how we can write the electronic configuration of an element? For answering this, I would like to recall your ideas about Bohr's atomic model. According to Bohr atom model, the central positive part of an atom is nucleus. Electrons revolve around the nucleus in specific orbit, and these orbits are associated with a definite energy and are called shells or energy levels. These orbits or shells are represented by the capital letters K, L, M, N, O, etc. The maximum number of electrons that can accommodate in a shell can calculated using the equation 2n square, where n is the shell number. So K shell can accommodate 2 electrons, L 8 electrons, M 18 electrons, N shell can accommodate maximum 32 electrons. Whenever the distance from the nucleus increases, the energy in the shell increases. At the same time, the attractive force between the nucleus and the electrons decreases. We can see K shell, which is closer to the nucleus, experiences less energy and more attraction from the nucleus. N shell, which is far away from the nucleus, having greater energy and experience less attraction from the nucleus. Then how to write the electronic configuration of an atom? The given atom is sodium. The atomic number of sodium is 11. Then atomic number of an atom is the total number of electrons present in an atom. So, what is electronic configuration? Electronic configuration is the arrangement of electrons in different shells. So, we have to distribute these 11 electrons in various shells. So, we can write the electronic configuration as the first shell, K shell, can accommodate maximum 2 electrons. So, the first shell, K shell, accommodate 2 electrons. The L shell, 8 electrons, and the remaining 1 electron enters into the M shell. So, the electronic configuration is 281. Then, we can predict the group and period using this electronic configuration. The number of valence electron tell you the group number. So, the number of valence electron is 1. So, sodium atom belong to group 1. Then the number of shells gives the period number. So, the period number is 3. I hope you got a clear idea about shell, atomic number and electronic configurations. Now we are going to look inside a shell. How the electrons are arranged inside a shell? The shells are again divided into subshell. So, a new concept is subshell. In shell, the region where the maximum probability of finding electrons is called the subshell or orbitals. They are also known as sub-energy levels. Subshell can represented using the small letters S, P, D, F. When we look into the diagram, we can see that the K shell contain S subshell. L shell have S, P subshells, and M shell having S, P, D subshells. N shell having S, P, D, F subshells. So, once again, K shell having 1 S subshell, L shell having 1 S and 3 P subshells, M shell having 1 S, 3 P and 5 D subshell, N shell having 1 S, 3 P, 5 D and 7 F subshell. Then how electrons can be filled in these subshells? I will give you the exact calculation in your notes. Then what is the meaning of the following? 3p. 3p means p subshell of the third shell. Then 5f means f subshell of the fifth shell. Then 3p2 means there are 2 electrons in the p subshell of third shell.